Alright, so here we're going to be talking about how to find the slope between 2 points on a graph. And really all that boils down to is finding the rise over run. So I'm going to repeat this phrase a lot. Rise over run really just means how much it's going up or down compared to how much it's going left or right. I'm specifically going to use that run to mean going to the right. So when I say that, I mean from this point to that point, how far does that go to the right? Counting just across to the right, how many spaces is that? When I say rise, I'm saying same kind of thing. From this point to that point, I'm counting how much it's going up there from that to that. I'm not counting diagonally. I'm just counting up or down for the rise. And really, I'm only going to count to the right for the run. You can count to the left, but I'm just going to go from left to right just because that's how we generally read a graph. The slope really measures how quickly something rises or falls going from left to right on the graph. So now when I want to find the rise over run for these 2 points, I want to count from this point to that point. You always want to start on the left side counting to the right side. And I just want to count out my rise first. How much is this going up from that spot to that spot? I'm not counting diagonally, just up 1, 2 spots. Now it's on that same level. It's at that same height. So to jump up 1, 2, took me from that point to that point. That's my rise, my positive 2. You don't really need to write the sign. I just wanted to emphasize that it's going up 2. Then my run, I'm going to do kind of the same thing. I'm going to count from this spot to that spot, but I'm not counting up or down this time. I'm counting just across. So I'm going to start at this point. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 spots to the right. My run is a positive 8. Again, you really don't want to write that sign there just because it's positive, but I just want to emphasize that we're going to the right 8, which on the x-axis is the positive direction. We're going up 2, which in the y-axis, that's the positive direction. So my rise over run is 2 over 8. That is my slope. I have found the slope between these 2 points. This is a simplifiable fraction, though. I see that I have a 2 on the top, and that's divisible by 2 on the bottom. So I'm going to divide the top and the bottom both by 2 to change my slope into a simplified fraction of 1/4. So really what that's saying is that for every 1 spot that we go up, we go over to the right 4. We go up 1, over 1, 2, 3, 4. And we really just continue that pattern, up 1, over 4. We can continue that indefinitely in that direction, and actually we can go backwards. We can count down 1 and backwards 4 spots and continue that line going in both directions. All right, so here again, we're going to find the slope between these 2 points. So again, that just comes down to finding rise over run. So from this spot to that spot, how much are we going up or down compared to how much do we go to the right? So I'm going to start at this point. That's the point on the left. And I'm going to count to the point on the right. And I'm going to just count the up and down direction, not diagonally at all. 1, 2, 3 spots down. Now I'm on that same height, that same level as this second point. So I went down 3. I'm going to label that with a negative sign. So my rise is a negative 3. And my run, I'm going to count from that exact point over 1, 2, 3, 4, 5, 6, 7, 8, 9 spots to the right. So that's a positive 9 as my run. So that is my slope. M is negative 3 over 9. Again, I can simplify that. I have a 3 on the top. That's divisible by 3, so I'm going to divide by 3 on the top and the bottom to get negative 1/3. So when we simplify this slope, it's basically showing the continuous pattern that's happening in between this point and that point. The original slope was showing that we're going down 3 and over to the right 9. This is just showing that in smaller increments. We're going down 1 over 1, 2, 3. Down 1 over 3, down 1 over 3. It's really just breaking down the pattern there. And it helps us extend this in both directions. Back 3, up 1, or I can continue down 1 over 3. That pattern, that slope, remains consistent throughout all of the points on that line. So here we see that that line is already formed for us. We have 2 points that are on that line, but we can actually use any points that we want from this line. The slope remains consistent the entire way up. So we can take these 2 points and use those to find slope, or I could take this point, because I see that's also on these grid lines. I could see that that's starting at -3, -9, so I'd also have an easy time counting from that to that. There's other points that we can definitely use in here. Any of these points that I can easily read off the graph so that I can easily count are usable to find my slope, because the slope remains consistent the entire way up. We might get a bigger fraction, but when you simplify it, it's the same exact slope. I'm going to use the 2 given points and then show that actually I could use any 2 points. But I'm going to take this and count my rise to that point, up 1, 2, 3, 4, 5, 6. So my rise is +6. And then from that spot over 1, 2, 3, my run is a +3. So my rise over run, that fraction simplifies to just 2. So my slope there is really just 2. This represents that I'm going up 2 and over 1 each time. So from this spot, which I can easily read on that graph there, I can go up 2 and over 1 and get to the next point on that line. And I could do that continuously through the entire line. So let's just show from this spot to that spot. Actually, the slope is identical. Up 1, 2, 3, 4, 5, 6. Actually, I'm going to keep it going even. 7, 8. Just so I can get the identical slope. I'm just going to show how it's the same, just represented with different numbers. This is going from that spot up to this spot. That's +8. And then going over 1, 2, 3, 4, +4. So there, between these 2 points, my rise over run is 8 over 4, which is identical to what I found between those 2 points. So here again, we can see that we have a continuous line that connects my 2 points, which really means that I can use any of the points that I see that are easily readable to count out my slope. If I'm able to count that easily, then really I don't have to count all this way from that point to that point. I could really use any of these 2 points. The slope should be consistent throughout the entire line. I'm just going to use the 2 given points anyway. I'm going to take that point and count my rise and run to that point. So the rise is going from there to there, just down 1, 2, 3 spots. So my rise is a -3. I'm dropping 3 spots going from there to get from that level down to that level. That has to go down 3, so I mark that as a -3. Then from this spot to that spot, I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So my run is a +15 because I'm going to the right there. So here my slope is -3 over 15. That can be simplified. The top can be divided by 3, and so can the bottom. So I'm going to divide each of those by 3 and get that my simplified slope is -1/5, or -1 over 5. What that's really saying is that I'm going down 1 for every 5 that I go over. So this is a little bit of a pain to have to count all that distance, and actually it gets much worse. So we don't always want to have to do this. When we see that we have coordinates here, we're going to see an easier way to do this with a simple operation. Going from that spot to that spot, I could just count that it's 15, or I can really just find the difference between these. I can subtract those two, 8 minus -7, and that gives me the same result of 15. So we're going to show later how to find the slope between coordinates instead of using the graph, just using basically a quick shortcut of counting, which is finding the difference between those two spaces. All right, here we have a special case of slope. So I'm going to actually do the exact same thing that I did before. I don't actually have points labeled on here, so I can make up whatever points I want. I can pick any points I want here. I'm going to just use this one and this one. I'm going to count my rise, but something weird happens here. That's not rising at all. Going from that point to that point, I don't go up or down. So my rise there is 0. It does not go up or down, and that's exactly what I counted. I just counted 0. Then to the right, 1, 2, 3, 4, 5, 6. So my run is 6, but you can tell that actually it doesn't matter. From this to that, my run would be 1, 2, 3, 4. that would be a rise of 0 and a run of 4. This to that would be a rise of 0 and a run of 16. All of those are going to be equal, and they're just going to be 0. The slope of this line is 0. It doesn't have any rise to it, so the top of this fraction will always remain 0. This is another special case where basically it's the opposite that's happening. We're going straight up and down here. So let's just make up 2 points to count between. From that spot to, let's say, that spot. Going up 1, 2, 3, 4, 5. So my rise there is 5. And my run is 0. That does not go to the right at all. It's just going straight up. However, we actually can't divide this fraction. 5 divided by 0 will give you an error message in the calculator because this is an undefined term in math, and we call this an undefined slope. It's undefined because we literally don't have a definition for this fraction. There is no way to represent this as a number because you can't actually divide something by 0. If you think about that in terms of like division as a grouping, you can't split something into 0 groups. You can also think about this fraction. If you think about this number as a changing number, let's say it was 10, and then it changes to 5. Well, let's say it changes to 2, and then to 1, and then a half. So this is really just all an effort to explain why we can't actually define this fraction and why we call this an undefined slope. If this number is dropping, going from 10 to 5 down to 2, the value of the fraction actually increases. This is 1/2, then it goes to 1, then it goes to 2.5, then it goes to 5, and then to 10. So as this number on the bottom goes down, the overall value of the fraction goes up. So if this were to go down to 0, that would go up indefinitely. Basically, it would go off to infinity. That is rising as quickly as it possibly can over the amount that it's running. It's rising infinitely over that span of run. We just address that as an undefined term because this is actually not a number. We just want to say that we don't actually have a way to describe that with a number, so we say it's undefined.